Welcome to Questioncloud. I'm Ram David, your physics faculty. Today we will discuss about the third chapter, which is the current electricity. Okay. So previous first two chapters we saw about electrostatics, where we studied about charges in rest. Okay, now from the third chapter we are going to see how the charges are going to behave when they flow through the circuit. Okay, that is why this chapter is called as a current electricity. Okay, so current means flow of charges. Current means flow of charges. Okay, first two chapters we saw we studied how the charges behave in rest. Okay, now we are going to see how the charges behave in when they flow through a electrical circuit. Okay, the first thing is we have to see the definition of electric current. So actually, what is the symbol of electric current? Always when you see any quantity in physics, make sure that you know and recollect the symbols properly. Okay, so electric current, the symbol is capital I, okay, which represents intensity of current. Okay, and that is why we put I. I means how strong the current is. That is called as the intensity of current I. Okay, so what is the formula for electric current? Is current I is equal to Q by T. Okay, as I told you before, your expression is the heart of heart. Okay, as you meditate on the expression, you will get all the definition. So how I define current, just see here. Q, it is defined as charge per unit time. Charge per unit, the flow of charge per unit time. So as you see the expression, you will get your definition. So don't need to mug up the definitions. Okay, so current is defined as charge per unit time. Always when you say when per unit time, you will always divide by T. Okay, these are all the things that you can have in mind. Okay, and the basic formula in physics will always be same, and there will be some mathematical expressions of the same basic formula. Okay, so this form can be extended to like this. For example, it can be written as del Q by del T, and limit del T tends to 0. Okay, this is your del form, that is change in charges by change in time. Like that you can do, or it can also be different in the differential form, that is dq by dt. dq by dt. So whenever you get d by dt, you can remember that you can put the word rate of flow of charges is only called as current. Okay, so wherever you have this d by dt, you can use the word rate of. So these are, so there is no, you don't have to worry about the definitions and all. Everything they will have a keyword like this. Okay, you just put the keywords and fill it up, then your definitions will be over. Okay, so I is equal to q by t, or del q by del t is equal to dq by dt, which is the differential form, but the basic formula will be same only. Okay, it can also have this integral form also. For example, dq is equal to I dt. Because I is equal to dq by dt, dq can be written as I into dt. So we can write, if we integrate on both sides, we will get cancelled. Then we can write q as q is equal to integral of I dt. Okay, so only the forms will change according to what are all the mathematical expressions that you are putting, but the basic formula is going to be the same, that is I is equal to q by t is the same. Okay, only the forms are changing according to whatever mathematical tools that you are using. If I use differentiation, it will become this form. If I use integration, then it will become this form. Okay, so don't worry about the change of form, but the basic formula is going to be the same.